Welcome back. So in this notes, we're going to continue our conversation about about radical equations and equations with irrational exponents. So really quickly, I want to go back and just do a quick recap of the two big ideas that we covered, okay? So one of the biggest things is keeping in mind you always have to isolate whatever special equation you're talking about. So if I want to isolate that square root piece, I need to divide by 2. So I divide both sides by 2. And now to undo a root, I need a power, right? So to undo a square root, I'm going to take both sides and square them. So that undoes the root, and then 2 squared is just the number 4. Subtract 1, divide by 3, and there you have it. And of course, now I don't want this video to get as long as the last one, but of course you go back and you can check your answer in there. And for this next one, same thing, I want to isolate that special piece of my equation. So I'm going to divide both sides by 2. Now that I have it isolated, now remember to undo the fractional exponent. To undo that, I need the reciprocal. Okay, so the reciprocal here is going to be 3/4. So that's going to break free that x plus 1. And now this is what you need to keep in mind. The power that I'm using is basically a root or an even root on the bottom, right? So whenever I have that even on the bottom, it means I'm going to need a plus or minus, okay? Because whenever you take an even root in an equation, you always produce that plus or minus. And then, of course, always feel free, you can use the calculator. So 16 to the 3/4. You can use a calculator to help speed up those computations. And that's going to give me an 8. Because of that plus or minus, now I basically have two equations. X plus 1 equals 8, x plus 1 equals -8. And so I'm getting two solutions. I'm getting a solution of 7, and I'm getting a solution of -9. And again, you can always go back and you can plug that in to check to make sure you got a legitimate solution, okay? And in this case, both of those solutions do work. Now, however, some situations do arise where both aren't going to work, okay? We call those, and I'm sorry, I'm going to have to erase this. We call those extraneous solutions, okay? So an extraneous solution arises when you get a solution that doesn't actually fit back in the original problem. So let me show you some circumstances where that can happen, where you can actually end up with solutions that don't fit the original context of the problem. So here the other trick to ones like these. The trick is here my square root is already alone, okay? I don't have any issue with that. So I'm already ready to square both sides, okay? When I square both sides, oh, I'm sorry. When I square both sides, it cancels the root, so it sets free that x plus 7. However, that x plus 5 quantity squared. So remember, x plus 5 squared really means multiplying it by itself. And then in the middle of your notes here, I gave you a little spoiler alert that remember, whenever you have that situation, that actually means that you have to FOIL that out. Okay? So foiling that out, x times x is x squared, 5x and 5x gives us 10x. 5 times 5 is going to be 25. So now here's a circumstance where we actually have a quadratic. So we can't use the same methods that we have been to solve this thing. Whenever you have a quadratic, remember the main idea to solve a quadratic is trying to factor it. Okay, so whenever you have a quadratic left over, remember the key line of attack that we usually use is we try to factor it. Now, of course, I can't factor it in this form, right? I need to subtract the x from both sides and subtract the 7 from both sides. In order to factor, it needs to be set equal to 0. So we would have that. Now, I need to factor this thing. So that's going to give me x plus 3 and x plus 6. So my two solutions are going to be negative 3 and negative 6. Now, this is where you need to be very careful, okay? Because I end up with a quadratic and factor and all that stuff, it's possible I've created a solution that doesn't actually work in the original problem. So I'm going to do a little bit of erasing here just so you can see what the original problem was, okay? That was the problem that we started with, okay? And we need to go and we need to make sure that both solutions work in that original problem. So I'm going to check this one in blue. So square root of negative 3 plus 7 equals negative 3 plus 5. Square root of 4 equals 2. 2 equals 2. That one checks out, okay? That one works perfectly. Let's check our other one though. So I'm going to check this one in green. So square root of negative 6 plus 7 equals negative 6 plus 5. So the square root of 1, well, here we have an issue. Because here, that doesn't actually match. 1 doesn't equal negative 1. So this leads to the dilemma of we have a solution now that doesn't actually solve our original equation. So what I'd like you to do in that instance is just put an x through it, okay? I want to see the work. I want to see, hey, I got this as a potential solution. However, it didn't actually work, so I'm ignoring it. I'm scratching it off, okay? So that's going to be how I want you to approach these types of problems. When you go back, when you check your work and you have a solution that didn't actually work, just put an X through it because then I'll still be able to see that you found it, but I'll know that it wasn't actually a solution that you wanted. So let's do another example of one that works like this. So again, first and foremost, I need to isolate this, all right? So I'm going to add, or I'm sorry, I'm going to subtract the 3 over, and now I'm going to square both sides. So that's going to set this part free. And then remember, on the other side, squaring something that looks like that is actually multiplying it by itself. And when you write it out twice that way, that's going to help reinforce the idea that you really should be foiling this out. X squared, negative 3x minus 3 more x. The negative 3 times negative 3 gives me that. When you have a quadratic, we talked on the first problem that in order to solve a quadratic, you're going to talk about factoring. But to factor, we need to get everything to one side. All right, now that I have that, now I can finally factor that. That's going to be x minus 1, x minus 10. So I'm going to get my two solutions of 1 and 10. But of course, it is going to be very important that we go back and that we check it in the original context of the question. All right, so in the original problem, I'm going to check this one in blue. So in the original problem, what that would look like is this. 5 times 1 minus 1 plus 3 equals 1. So this would be square root of 4. So here, I think you can see, oh, sorry, that should have been an equals. We end up with a situation, okay? We end up with a completely nonsense answer, right? 5 can't equal 1. So when I was checking my work, I found something that didn't actually work in the original context. So remember, that means just put a nice X through that solution. And now let's check 10. So I'm going to plug 10 in there as well. So that'll give me the square root of 49 plus 3 equals 10. 7 plus 3. So this one did work out. So the x equals 10, that solution I am going to keep, okay? That did work out in the original context of the problem. So these take a little bit more work, but completely doable as long as you're diligent with all of your work and then checking at the very end to make sure that you have the right answer. Now, there is one more type of problem that I want to talk about. Okay, the situation where here, what if you have two radicals and you can't just get them equal to each other, right? There's two radicals, but you have other stuff in there as well, like the fact is set equaling 1. So I'm going to talk you through a process that'll get you through this type of problem as well. Okay, so step number 1. Step 1 says isolate the more complicated radical. So here, I think we could agree this is a more complicated radical, right? So that's what I'm going to isolate. So I'm going to get that by itself by adding the square root of x over, okay? So in doing that, now I have one of my roots by itself, right? So now that I have one of my roots by itself, I can actually square both sides. So let's see what that gives me. Well, that breaks free that first root, okay? And remember, if I'm ever squaring a binomial like that, really it's the same as multiplying it by itself. So now I need to FOIL this thing out, okay? So 1 times 1, 1 square root of 2, plus another square root of 2. So that's going to give me 2, oh sorry, not square root of 2, square root of x, sorry. Square root of x plus square root of x is 2 square roots of x. And then square root of x times square root of x, well, that's going to set that one free as well. All right, so let's see what this gives me. So now I need to re-isolate that square root, okay? Because now if you notice, I do still have a square root in this equation, right? And so I do actually have to go and re-isolate it. So what that means is I'm going to subtract an x from both sides. So I'm just going to have an x minus 1. Well, that actually cancels both of my 1's. All right, now I need to isolate that square root, so I'm also going to divide by 2. And now finally that square root is by itself, so I can square it. So I'm going to get x squared over 4, and it's just going to set that free. All right, So now I'm actually going to multiply that 4 back over because I don't like having a fraction like that. But now the big thing is, so I have a quadratic again, okay? And remember, when I have a quadratic, the big idea is to be able to factor. So I'm going to move this 4x over. I'm going to subtract it over because remember, to factor, I do need to, it said equal to 0. And to factor this, well, this time my x is in both terms. So really all I have to do is pull out that x. And now I have my two pieces, right? And hopefully you remember, whenever you have an x out front, it's just an x equals 0. And then this one would give us x equals 4. So I have my two solutions. Now let's go back and check them, okay? So we need to check these back in the original problem, all right? So let's go and actually do that. So I'm going to check my solution of 0 first, okay? So let's check that one, and I'm going to do it up here just so I can see the formula as I'm working with it. So 2 times 0 plus 1 minus square root of 0. So here this is going to be square root of 1 minus square root of 0. So 1 minus 0 does in fact equal 1. So that one worked out perfectly. And now let's check the 4. Okay, so let's plug the 4 in. So 2 plus 4 is 1 minus square root of 4. All right, so here we get square root of 9 minus square root of 4. 3 minus 2. So here, both of those solutions check out, so I would get to keep both of them. All right, so that was kind of a doozy. Now this one, to be honest, is above the skill set I'm looking for the test. This is exposure for all those standardized tests that you are going to encounter in case I throw one like this at you. So you have the skill set that you need as you go on in math, or if you see something like this on a standardized test. Now let's end with a word problem, and then I'll set you guys free from this. So a function for the distance in meters which a car needs to stop is given by d equals 2 square roots of v, where v in meters per second is the speed of the car before braking. Oh, and that should be car. What is the speed of the car before braking if 8 meters of distance are needed to stop the car? So this 8 they're giving us is the distance. So that I'm going to plug in for the d. And now after everything I made you do in this notes, I'm hoping that this is a super simple solution or super simple problem for you to solve. You can divide by 2 and then just square both sides. So V, we're going to be talking about 16 meters per second. Okay? So it was going 16 meters per second if it needed 8 meters to stop. Okay, so then after everything you've done, probably that last one is just kind of a breath of fresh air for you. So I do want you to scroll down though. So again, a lot of good stuff today. So why don't you write that summary for me? Again, hit the key highlights that you want to make sure you remember as you move closer to the test, so you know how to keep all of these different skills straight in solving these equations. Once you're done with your summary, then make sure you just come back ready to do your practice work.